Solve the rational inequality x minus 1 divided by x plus 2 is greater than or equal to 0. So remember, first we have to write end our sentence with 0, and it already is that way. So we also have to check, because it's a rational function, that it's a single fraction, and it already is that way. So we are going to proceed with simply what's printed above: x minus 1 plus x plus 2 is greater than or equal to 0. So it's on the right side and it's a single fraction. Now we need to find the zeros of f of x. So we just have to set the numerator equal to 0. And we can read that solution. It's just x equals 1. Add 1 to both sides. Now find excluded values. We set the denominator equal to 0. And we can also read that solution because we just subtract 2 from both sides. So we have excluded values of -2. Now we're going to use the zeros and the excluded values to divide the number line into regions. Remember, this number line represents the x-axis. So let's say here's about -2, and then maybe here's +1. So we have two partitions, or two values, and we have 3 partitions. So we have a section A, a section B, and a section C. Now we need to choose test points between each of these sections to test whether or not they're positive or negative. And since this is a greater than or equal to 0, we want the positive regions. So let's start crunching some numbers here. Let's choose x equals -3 for section A. So f of -3 is -3 minus 1 over -3 plus 2. So that equals 4. It's positive. So is it a solution? Yes, it is. X equals 0 is between -2 and 1. I love when we can use 0 as a test point because we have a very quick evaluation. So that's -1/2, and that's negative, so it's not a solution. Now let's choose a number greater than 1 for section C. So that would be 2 as an easy number to use. So 2 minus 1 over 2 plus 2, so we have 1/4, and that is positive. So that is a solution. So section A is positive, section B is negative, and section C is once again positive. So now we're going to shade the number line where we are a solution. So wherever we have positive section, we're going to shade that number line, and we're going to use a bracket for the 0. But remember, -2 was an excluded value, so that will be a parenthesis there. And we're going to shade section C, but we're going to use 0, the 0, 1, put a bracket there because we have the equal bar. So now let me slide that up just a little bit and write down what I just said. Since we're solving a greater than or equal to, we're going to use a bracket for the 0, which was +1, and we're always going to use a parenthesis for excluded values, and that was -2 was an excluded value. So writing the solution in interval notation will be -∞ to -2 with a parenthesis, union, bracket the 1, and go to infinity. And once again, instead of sketching it by hand by ourselves, you can go to any graphing app that you choose and sketch the graph. So I'll just jump over to Desmos, and I haven't typed this one in yet, but we can do this together. And it's real easy to get a fraction in Desmos. You just hit the / and it'll make it into a fraction. So if we did x minus 1 and then hit the fraction, oops, nope, I had to put parentheses around that. So x minus 1 and then hit the fraction, I mean the forward slash, it'll make it into a fraction, and then x plus 2. I don't really have to use parentheses there, and I'm just gonna find where this is so we can kind of see the whole story a little bit. So we have two like opposing branches. We didn't really analyze the whole function, but we get the gist of this sketch here. So I'm just going to try to get that in my head and go back to our paper and sketch that quickly. So we had a vertical asymptote about here, and we had a horizontal asymptote about here, and then we had this branch going something like this. It wasn't going through the origin, and this branch going something like this, and we only want where we're above or equal, where we're positive, I mean. So it's above the x-axis when x is strictly less than -2 and when x is greater than or equal to 1. So it's this piece here and this whole piece here. So we were looking for where it was above the x-axis. X was strictly less than -2 because x equals -2 was an asymptote, and x is greater than or equal to 1 because x equals 1 was an x-intercept.